So, second talk with ScalaUA. Today we are here and we talk about Akka on ScalaUA. That is Akka.Js, that is this project just to underline that ScalaUA is so cool. And first of all, the boring part, I'm not the brown one, ever. And yes, I'm Andrea, I'm an Italian guy. I usually work as on software engineering, wherever fields, from PLC, embedded system, FPGAs, cloud, cluster, Spark, whatever, front-end. It happens sometimes. And I have experience in every field, and I really like just to code. Code well done. And first I know Scala in 2008, thanks to the actor library that was bundled into the standard library at the time. And I started the Scala there. And now I work for Nokia in Lisbon, and we are doing some big data stuffs. My handler on GitHub are Andrea Peruffo. You can reach me out. But this project, Akka.Js, born under Unicredit, my former job, and I have to really thank them for starting this out because it's great. So, first of all, I think everybody of you, since we are at a Scala conference, knows what is Akka. Akka is a library that gives you the actor framework for Scala and for the JVM itself. The actor model is really great, and it's basically just three things. It's just the ability of spawning for an actor to spawn a new actor, the ability for an actor to change its internal state, that means maintain its internal behavior, that it means maintain its state, and the ability to send messages. So you avoid basically shared memory, and you get rid of a lot of bugs and ugly things you can face programming with threads or with a classical model. Akka is a really mature nowadays implementation of actor model. A lot of systems rely on it, and it is really cool and developed full time by some really great guys. And the only comparable thing in the actor model is obviously Erlang, that is the one former implementation of the actor, and it's an entire language. But Akka is great. And the second thing we should talk about is obviously ScalaUA. We are now at version 06.15, but Duran, that is the creator of ScalaUA, is going to 1.0, I believe, within the end of the year. It's a really solid implementation. Already there are people that are using it in production, and it is really from the ground up developed with the same principle, great eye to performances, and it is a really great project, and Luca talked about it previously enough to know a little bit about it. And yes, from the union of the two, what I want to do at some point is to take Akka, that is a great library with the actor model, and I want to run it on JavaScript, in the front end or wherever, in JavaScript VM. So, first of all, this is the point in my presentation where I start to explain how does Akka.Js work under the hood, and I have to talk about compiler plugin, Java standard library, reflection, intermediate representation patches. But for this time, I don't want to bother you with this kind of things. It's just, who cares? I don't want to know what is running underneath. I don't want to know how Akka.Js is built. I just wanted to use it, because this is what you should do. And why you should care? Why not? No, I'm joking. I try to be serious. I don't want to explain you point by point why you want to use it. I want to show you with an example. So we take an exercise, try to develop it all with Akka.Js, ScalaUA and Akka.Js, from backend to front end, and do everything using Akka.Js and vector model, and see how it works and how it could be done by us in our daily job. So, for example, we take just a POC, proof of concept. We are asked to do it fast, do it dirty. I don't want to know anything about. I don't want to care about the models or whatever. Just do a POC of a Twitter streaming service from backend, full stack, from backend to front end. So, what we have to see is, first of all, the backend. And yes, I forgot. Is the backend. So the server, as you can see, what you need to develop a ScalaJS project is basically simply this import. You need to add the SBT plugin of ScalaJS within plugins SBT into project, and then to enable the plugin into, you can see it probably better, and you can, and you have just to enable the plugin into your project, and this becomes a ScalaJS project. This means that it will run on your JavaScript, or in your favorite JavaScript virtual machine, and at this point it will run on my preferred one, that is Node, that is installed on the side. And I just have to define a couple of dependencies, Akka.Js actor and Akka.Js test kit, for running it. What we have to do. So, first of all, we can try to analyze our application, what we want to achieve, and design how our application will be written. First of all, we need a component that is an handler for WebSocket request. So we will have WebSocket request. We want to do it we want to do everything in stream, and we handle WebSocket request with a server that will be mapped by an actor. We'll have an actor that runs the server. This WebSocket server that is an actor will spawn a new actor that will manage each WebSocket channel every time a connection comes in. So we have completely separate fields. We have the server that accepts requests, and every request will be managed by a separate actor. We will have to write our logic just once, and it will be delivered to separate channels automatically. Another service that we need, of course, since we want to connect to the Twitter streaming API. The Twitter streaming API is a Twitter service that will connect our WebSocket connection to the Twitter streaming API, and for example, track some topics and redirect messages to the front end. And this will be another actor that will be created on a per channel way. I'm not a Node developer, but I was said that developing application on Node.js it's easy. Everybody can do it, and I see young guys just googling and copy and pasting code, and it works incredibly. Sometimes it crashes, but they have Docker or whatever, and everything looks fine. There are entire startup based on Node. So what I have to do to start a WebSocket server is Googling, and the very first link is I need a WebSocket for npm, and okay, there is a package. It is called WebSocket, and I want some example code. Go down. Here we are. This is some example code, and what we have to do to install and use it is simply npm install WebSocket into the same directory that we will use for our project, and then we can directly use this example. So basically, we just copy and paste our code, and you can see that. We are doing basically the same thing. We require the module HTTP. We don't want to see line by line, but what happens is that just we create a WebSocket server, we link it with HTTP server that we already created. We need some basic configuration that is here written, and we are just copy and pasting, and we want to go to the beefy part that is using this web server on a request do something, and in this case, since this is JavaScript, obviously everything is managed by a callback. First callback, this is a function that takes the request and do something. What we are doing is mapping directly this callback, this request callback, to the action of spawning an actor. That will be the actor that will manage the single connection. And we pass to the actor the connection itself. This is we are decoupling things. And as you can see on JavaScript, we started to go nested and nested, and so the connection here is nested into the other one and is managing the server. We don't want to go like this. We simply spawn an actor, and then our server will listen on a port. Easy enough. We should go for the second component of our backend architecture, and that will be obviously the WebSocket channel. It's an actor. We haven't seen it, so go to see it, and our WebSocket channel is pretty easy. It get a connection inside, that is the dynamic object got from the library that we are using, and simply during the press start it initialize another actor that will be the Twitter one for receiving and sending messages, and simply when this actor receives a message from whoever, it directly send it over the WebSocket connection. This is very meaningful part. It's like an echo, but it simply redirect a message over a specific channel. Since we are using Akka and since we are using Scala, we can also test this code, of course. So, for example, we can have a WebSocket channel, and we can add a probe like we do with testkit usually. We can mock our WebSocket channel describing just an object that will have a callback, and that will be, and we pass it to the constructor of the actor itself. We can so send messages to this actor and expect that the probe will receive the very same message because it is sent through our callback. And what we can do is to run our test on Node, and this will compile and generate JavaScript. And yes, okay, we can send messages to our WebSocket channel actor, and this message is directly redirected to the JavaScript callback. I think it's quite easy, sincere, and we can go to the next component we wanna describe, and it's the Twitter service. I don't know how to connect to Twitter. I don't know how to connect it using Node. First thing I do is to Google for it, and there is a Node module for doing it. Every time you can find a Node module for doing anything. So npm install Node Twitter stream, and this is the example. And the example code is really easy. You just need to require the Twitter and provide some keys, for some credentials for accessing. And you have 2 callbacks on tweet, on error, and this logs something, and you can track some topic. What we do in Akka.Js is to just describe our new Twitter actor that will receive objects that are tracked, so he can track some topics, and he will answer sending to the parent every time the new message. What we have to do is to just copy and paste the example we found on the internet, and we require Node tweet stream, and we have our new instance created with my credentials, and I bind the action, the callback of receiving a tweet to the send of a message to our parent. 1 + 1 + 1, what happens is that from the Twitter actor, the message is received from the Twitter service, sent to the WebSocket channel, and then sent over WebSocket to the UI. And these are simple actors, few line of code. Yes, and this actor obviously, when he receives a message of tracking, it just track the new topic on the Twitter service provided by the Node module. We can write a simple demo to see if the Twitter actor is working, and this simple demo just create an actor system, spawn one single Twitter actor that will track one common topic, just to see a little bit of output. We send to him a message that is tracked, and he will track the pizza topic, and every time you receive a message, you will print it. And we can run it, and we see if our connection is working. Our connection is working, and we are receiving directly our streaming from Twitter and posting it to the console using Node.js and Akka.js, and we are done. We already have done everything with our backend, and we are okay with it, and it's good. What we have learned from this lesson, from this very first and brief approach. First of all, concept separation. We are using actors. I can never stop are the original object model, or are the real object-oriented programming, and we separate every concept. So we have a server, we have a channel, we have a Twitter service, and for each of them we have an actor. We separate the concepts, and they are directly binded to some very simple code that encapsulate not only the properties of what we are managing, but even the behavior. That is the important point for using Akka. We get rid from the callback. The callback is a well-known problem in every JavaScript library, as you have seen from a really simple example of the server. You start to go nested, and it was a trivial example. Since you have the opportunity to bind every callback to a spawning actor, just sending messages, you have just one single level of interaction, and you have everything that composes really well, composes really better, and you don't have anymore to write your code within our functions or to fall into the callback. And even really important, we have a free concurrency isolation. We just define, for example, one WebSocket channel actor, and it will take care of one single WebSocket. So when we write the logic that will be applied to this channel, we write it once, thinking about one single channel. We do not have to struggle with a sequence of things that are going around. We don't have to keep track to all the connection. We have everything completely separated that will run concurrently on Node, not in parallel obviously because it's single-threaded, but we have real concurrency isolation for free. And all our service is less than 150 lines of code, so it is really easy, really fun, and we just Google a little bit. We have everything in our end, and we just model what we think at the very first, and it is great. Now, we try to go to the next step. We have to develop even the front end, and we want to do it with Akka.Js again. Our project will look really simple as well, and we have the import of ScalaUA for our SBT as an SBT plugin, and we define a project that will use the ScalaUA plugin itself, of course, and we import some dependencies. These ones are all for testing, and what we need is just this. We have Akka actor and Akka strings to be a little bit fancier, and we use even Scala text, and we have one JavaScript dependency. Later we will see why, and a few options to have it. Our front end will be an HTML page, but our HTML page is just some bootstrap and importing our JavaScript produced code and having an handler to hook into. This is just my page, and everything will be done by the code we will produce. And this is a very simple and basic SPA written with ScalaUA, we can say. As well, we try to track and we try to imagine what we want to describe into our front end, and what we want to see, and what will be the behavior, what will be represented. And first of all, of course, we are in front end, so we want to develop the UI. And the UI will be mapped on the DOM. You can see the DOM is a tree of nodes, as everyone knows. But let's think a little bit. And actors in Akka are modeled like with a hierarchy. So on one side we have the hierarchy of nodes for the DOM. On the other side we have the hierarchy of actors, and they can match. So you can bind some you can bind some node of the DOM on representing an actor with a template and just hook it, and you have a complete representation of your DOM into the backend, done really granularly and with actors. So you don't just describe the template, but you describe even the behavior of your piece of DOM. And the second component we obviously need is the WebSocket channel. Again, we have to get the messages that are coming from the backend, from our Node backend, directly pushed to the DOM in some way. And for this, since once we track some Twitter topics, we will have a stream, and we want to model it like a stream, like our new fancy libraries let us do. A UI. We start with a UI actor. We want to have a navbar, a tracker, just to write inside the topic to follow, and the carousel that will show one by one in a nice way our received tweets. We have our UI, and this is quite easy, because we are using actor, and everything becomes easy. So we have just one actor that will describe, okay, from here we will start, and so it's an empty div. Its template is represented like an empty div, and we'll just spawn new actors under him to display the three separate parts that I already mentioned. Here you can see my magic for doing this. That is my DOM actor. That is my super cool and fancy, let's say, web framework for doing the UI, and it's less than 1,000 line of code, as you can see, and it implements in-place replacement with just modifications of the HTML. That is what I'm using for the JavaScript library, because what happens is that if you have in mind your page and you granularly define each piece of the page with an actor, you don't have to have all the boilerplate gotten from the virtual DOM that is nowadays trendy. You already have some separation. If you have a modification within your specific actor, you have just to modify this specific piece of HTML. So I just make a diff from HTML before and HTML after in this particular section, and I apply the modification, and I apply efficiently the modification using this JavaScript library. This will be really much efficient than recalculating an entire page every time. We are doing it in a smaller manner because actors give us the opportunity of thinking granularly enough to do that, and this are just helpers for hooking into the HTML, adding some simple node, and that's it. But you can read the code after it is published, and it's really trivial. What our UI actor does is to spawn the three components, and the navbar actor is just composed by its template, and it's most about CSS and Bootstrap or whatever. It's just a template defined with Scala text. And then we have our tracker actor that will be an input stream, an input box that will have also a button that simply take the input box value and send to the parent a message to say, track this topic. Again, we have a callback, we have our button, and we have the action. We have the action of onClick that is marked. It is a callback. We just get the value, the actual value of the input box, and we send a message to our parent without thinking anymore. Our carousel actor, that will be the one that will show the different tweets, is done using obviously a template again, and it will show the new tweet every time, just sending to himself a message to update the value anytime you receive a new tweet. The glue from all these pieces is driven by the parent, that is UI actor that we defined before, and the UI actor will spawn the Twitter source that will provide him the new messages to the new tweet messages, and the father simply forward them to the carousel, and every time you receive some track message from the tracker, you just forward on the other side to the Twitter source the track message. So again, it's a simple message passing. I want to do that. Okay, send to my parent. Okay, send back to me or whatever. Is really, really easy. And as you can see, is mostly defining the DOM, how it should be rendered. And I have here our page, and our page will look like this. So we have our navbar, we have our carousel that now is initialized with the waiting first tweet message. And we have our next actor, that is the tracker. And if we want to add any other elements, we just need to spawn a new actor and do the same thing. The same model apply really well here. We have our UI in place. It is not that cool, but it will work for what we need. We are just asked to develop a POC, so we don't care too much about CSS. And we want to describe now is the WebSocket channel itself. And since we have Akka stream provided by Akka.Js in the front end, we will have a WebSocket that is connected to a stream that will send messages to the UI actor, as we have seen before. What happened is that we can describe our Twitter flow as with a Akka streaming API that is pretty cool, and we can map every string we received to a parsing of a JSON within it. We extract the username and the text simply, and if something goes wrong, we just simply retrieve none. We filter just the defined messages. And since we are talking about UI, we want also to implement some control flow on this stream. So we want to throttle it, because I don't want to receive all the Twitter one by one. I cannot even see them. I want to, for example, receive one message. I have to have the time to read it. Okay, 1 hour, and so we say that. Between one message and the other, we will have 750 milliseconds to wait. And this is pretty easy because it's done with a simple flow. If you have ever used the Akka stream, is something really easy and that maps really well the concept. On the other side, we have the tweet source sector. That is the one that is spawned by the actor that manages the UI, that implements our flow, obviously, and the source will be a queue, and the queue will be filled one by one every time I receive a message on the WebSocket handler. So the WebSocket handler will call the callback on message, and again, as soon as we have a callback in Node and in JavaScript, we go away doing something with the actors, or in this case with the stream, and we offer into the input source of the Twitter flow the string of that is contained in our event sent from the WebSocket. And the sync is the actor himself. And when the flow will finish, I just send a poison pill to myself just to clean up everything. But what happens is that every time I receive a tweet from I'm an actor again, and every time I receive a tweet from this Akka string, I just forward it back to my parent, and my parent is the UI, if you remember. So it's pretty easy. And the other way around is every time I receive a track message, I just send over the WebSocket back the track topic that I want to track. And on post stop, obviously, we can simply close the WebSocket and whatever. So we can try to run. Yes. Error. No, Ctrl+C before. we are running it, and we can refresh our page to let things connect, and we can track, for example, pizza. Yeah, it's working! We are receiving. And everything is isolated, and I just described everything, and both on the server and on the client we have concurrency handled in the proper manner. Every time I spawn, I open a new page, I can track, I don't know, another topic, and that, yes, okay, we have everything tracked with concurrency, and just describing one single flow using actors in a proper way, done on the backend that is Node, on the front end that is the web page, and we also realize our UI from there. What we have learned from this? First of all, we used the same programming model. We use actors in the backend, we use actors in the front end. We don't care. We don't have to think about, oh, okay, we are in the front end, I have to use React, or I have to use Elm, or I have to use whatever. I program in Scala in the backend, and you normally use Akka actors. Having to switch your mind between different programming models is a burden, and it require time to get used, and it requires times every time you make the switch. Here, you are not doing it anymore. You are just spawning actor in the backend, spawning actor in the front end, and you don't care about what is happening. You have reusability. Of course, ScalaJS gives you the opportunity to reuse code, for example, algorithms or whatever. You write them once in Scala and you can use them in the backend and in the front end. What is missing? Is missing concurrency and behavior. What happens is that your algorithm can be something that is more complex than a simple sequential algorithm. If you think about algorithms for consensus, Raft or whatever, they are behavior, and they are algorithms that are constituted by state that is mutating in the time and messages and whatever, and you can reuse them from front end to back end, and this is impossible without you can describe them with actors, and you will have them run on both client and server, because concurrency is provided for free for you. Otherwise, you have to completely rewrite them in a way that is done with callback or some really wired stuff to make them run properly. And then we have some free framework features. I basically didn't anything for having Akka stream running, and we have everything for free. It's here. I just ported Akka.Js, Akka to ScalaJS, and we have also Akka stream. Akka stream is a fantastic DSL. It has a number of helper methods that let you describe things really properly and really well, and it is completely available in Node, in the front end, in any JavaScript virtual machine that are free on the internet. There are tons on the internet for free where to run your code, and all the front end is less than 300 line of code. So with 450 line of code. We do all our POCs, and our manager are happy, and we can go on. I just wanted to say a few words about Akka.Js, the project itself, to conclude. And first of all, it's Akka. It is really Akka. I have some statistics here, and as you can see, I basically cross-compile starting. My starting point is cloning the GitHub project of Akka, and then I put every file into the right directory. And what happened is that I cross-compile 24,000 line of code, more than 24,000 line of code from the Akka sources, just providing less than 4,000 from myself. And again, Akka Stream, it comes basically for free. The 1,000 line of code are most copy and pasted. We just need a little bit of refactoring that we can push upstream really easily to reduce them to few hundreds. It comes everything for free because Akka Stream is just a DSL on top of Akka. So as soon as I provide the basics, I have everything, and I have the great engineers of the Akka team that are developing Akka and giving us all the nice abstractions they are doing, that are producing code that I can reuse in Akka.Js at any time. What next? Next steps for Akka.Js. First of all, I really want to have it. I really need to find the time to implement it, since I do not do Akka.Js in my working hours, but just in my spare time, but is implementing remote. If you have a remote transparent communication between the client server, but even between JavaScript and JavaScript, since web workers cannot have a shared memory, you can have transparent communication between web workers, and this is a powerful feature that will be enabled by having remote working in Akka.Js. And we have, of course, some JavaScript high-level binding for interoperability. I already started doing something, and it looks promising, at least for me. And at some point, if you are a JavaScript programmer, you can have something that looks really close to our Scala code, but there is, of course, JavaScript, and it runs Akka underneath. And but this should be exploited, and there are more code to do. And I'm working also on performances. This is a crucial part for having everything work really well. I have started something, but there is much work to do. They are not bad, but they can be much better. We can port, of course, other modules like Akka.Typed will come basically for free. There are, I think, a couple of files that should be changed. It will be really easy to port Akka.Typed to Akka.Js. And yes, many other plans, but a little bit more far. We are at the end. Thank you, and remember, if you wanted to join the effort, you can help, and yes, please. Check out.
Thank you for the great amount of work that you've done on porting Akka. I have a question. Have you discussed with Akka team if they can integrate shared and JS code to the code base?
They said yes. The answer is yes first, and the answer is they don't want. Because they say that they are basically just Java and JVM oriented engineers. They do not have anyone that knows anything about ScalaJS within the team, and they do not want to say in any sense that Akka.Js is supported, because they from a commercial point of view, they do not have the competence also to support really the project, and they don't want to merge it into their code base.
But they can just mark it as experimental, and if they mark it as experimental, they have no legal obligations to
Please, bug them with me.
Okay,
we can go on.
I will do. My main concern is that if it's not, if Lightband doesn't officially support that, how can I be sure that, for instance, no new version of Akka comes and you will update Akka shared code and it will behave the same way? As I understand, you use the same namespaces, right?
Yes, I clash completely. I use exactly the same namespace, and they are, you can port your code directly. You just need to compile. But what happened is that if you wanted to join the effort again, what you need to change for changing the Akka version is just to change this line. That is basically the tag on GitHub for the Akka original version, and try to compile with the newer version of Akka and go through the compiler errors, and you will have a new Akka.Js version running.
So how many active contributors you have?
Next question. No, few. Basically, right now is work from me. It was started by one intern I had at the time when we started the job, and there is basically one big contributor that basically ported the Akka stream implementation once and helped during the Akka actor test. But what happened is that I tried to minimize as much as possible the differences from Akka and to work on some simple components that will enable me to do as less work as possible, and this enabled me to port to the next version within 1 hour, 2 hours of work every time, and this is affordable just by me. And what happened is that this is real, and I rely, for example, on compiler plugins, patching the intermediate representation of ScalaJS itself, some other stuff. But at the end, what happened is that all the magic happens during the compile automatically of Akka.js itself. So if you have something wrong somewhere, you will see it first, and your user will not experience it.
I see. And have you tried to use it with web workers and WebRTC?
I started, in a sense. We have a very old proof of concept. I started also to refactor the whole Akka remote module to integrate it properly, because we will have different Akka remote implementation. The default one that you are running on Akka remote is the native based one. Usually, if you are not on Artery, the last one, but you can plug this implementation into Akka, and they are configurable. And what I want to do is to develop the Akka remote extension needed for running it over WebSocket, JavaScript channels, WebRTC, and all the stuff.
Okay, thank you.
Sorry, maybe I've just missed that, but the question is pretty simple. To have the main endpoint for front end, we mark the Scala class with annotation like JS app or extend JS app, and then we run it for the backend. Do we need to do the same, or what is the main endpoint for Node.js?
Okay, it is exactly the same. Sorry, I don't show you the main, but it's here. Our main is as before as a JS app, and this will be the code that will diverge from a JVM based from your JVM based one and the JS one. And you just, in this case, we just spawn the actor system and spawn a simple WebSocket server actor, as we have seen. This is, and I load the credentials from file system. Yes, but. This is the entry point for Node. You just have to run a function, and this is mapped to function, and you can run it. And you can do it directly within SBT also as well. But you have also the opportunity to run it directly using Node, providing the JavaScript compiled one without SBT. Other questions?
I want to ask about the routing, because even if we have a single page application, we still won't have browser history. And what about the routing in Akka.Js?
Yes, I can show you my first slide here. I believe. Don't call me front-end framework. I'm not developing a front-end framework. You can implement as I have done for the DOM, using some DOM diff to do the magic instead of having a virtual DOM, or it will be really easy to implement it with actors, because you just have to spawn the right actors to redirect your incoming request to the right rendering tree, let's see, and you just have to send a poison pill and creating new actors when you want to change. It will be really easy, but it is not the real final target of Akka.Js. Akka.Js is just for providing you concurrency and vector model that is really powerful, and these are kind of abstractions, kind of implementation that will come later on built on top. Thank you. So, thanks a lot. Reach me out if you want to know anything else. Bye.
Scala developers should take their code as simple as possible and try to achieve simplicity, doing things in a functional way, in a better way every day, and I aim to contribute back to open source communities. As far as we share our knowledge, and as far as we can share our competence and our code, we are growing and getting better in our job and in our knowledge, of course.